Okay, I'm going to teach you a skill today. The skill we're going to practice is creating a linear function. Now, before we begin, there's a few things that I want you to understand. One, when you see the word function, okay, I know most people get confused. Like, what is a function? There is a formal definition of a function. However, when it says write a function, or it says what is the function, or this is y is a function of x, what's something that you can easily refer to is the fact that they are also referring to an equation. They're referring to a formula, a rule. All of these words, okay, should pop in your mind when you hear the word function. It's a relationship, just like all of these are some sort of relationship, and we usually signify them with numbers and letters. Now, because we're talking about a linear function, there's a specific relationship that is repeatedly used, and it is written in this format: y equals mx plus b. Okay. Now, y and x are pretty simple and straightforward. We find y and x on a coordinate plane, on the x-axis and the y-axis, which makes it really nice to be able to draw certain graphs. There are two components of this formula that we would really like to know, so we can have it written out in a nice formal way. One is the slope, represented by m. Another word for the slope is the rate. Often in word problems, you won't see the word slope, you'll see rate. Like with the rate you get paid, the speed you're traveling, it's a rate, or miles per hour, and we'll get into that more later. B is known as your Y-intercept. Often I'll abbreviate that with Y-INT, just because, well, mathematicians are slightly lazy, and so we don't want to write the whole word, because we all know that's hard. This is the Y-intercept. It's the place where our graph, this is the graph right here, this graph hits the y-axis, and the y-axis is this really straight line right here. It goes up and down. So wherever these two lines cross, that is going to be considered your y-axis. So in this case, it'll be about right here, which if I counted from this dark line, 1, 2, 3, it'd be 3. So our y-intercept here would be 3, and we'll get into that later. I'll write that for future reference. Okay? Well, our goal for each of these problems is to write a linear equation for each of them. Well, these ones right here, 1 through 4, are right nice and easy. Look, it gives me what the slope is, it gives me what the y-intercept is, so all I got to do is substitute it in. Alright, y equals mx plus b. M is my slope, so that's 5, so y equals 5x. B is negative 3, so negative 3. Notice how that negative, just make sure it's a subtraction sign. That's it. That's all there is to it, and that's all there is to all 4 of these, so I'll leave you to that. Alright, number 5 gets slightly harder. I'll zoom in so you can see it better. Number 5 gets slightly harder because they don't give you the y-intercept. And you're like, what should I do about that? Well, that's not too bad. I'll show you what to do. Okay? So, remember, our goal here is y equals mx plus b. We want to fill this formula out. So first things first, we know what the slope is. So y equals 4/5 x plus b. Alright, I still need to know what that y-intercept is, the b. Well, fortunately, they've given us a point. Okay, 5, 3. That's our point. Alright, well, what's the point of the point? This is an ordered pair. It fits on our coordinate plane. So that means it's ordered like this, x, y. Now, we can figure out what something is based on the hole it leaves. So if I put all these variables in, I have a hole here, but if I simplify it, that disappears. I know exactly what should go there. Okay, so for instance, here's y. Y is 3, so y is 3, and then I got 4/5 for my slope. I'm going to substitute 5 in for x, 5 in for x, plus b. And then we're going to simplify this. Now, at this point, this is a skill that I will not teach you, multiplying fractions times whole numbers. If you don't know how to do that, please look it up. But when I multiply 4/5 times 5, it simplifies to 4. So I got 3 equals 4 plus b. And I subtract 4 from each side. 3 minus 4 is -1 equals b. Okay? So our y-intercept is -1. But we are not done. Remember, the goal of this whole problem was to try to figure out y equals mx plus b. So I still know the slope is 4/5. But now I know that my y-intercept is -1. So I have figured out the equation and I've found that. Okay? So that would be the answer to number 5. 7 is going to be a little interesting. They didn't give us any numbers. All they give us is a line on a graph. So we know how to find the y-intercept. I showed you that early on. So let's move over here to this graph here where we found that y-intercept. Okay? So our y-intercept here is b3. All right, I'm going to move back because I shaded those lines, so it's a little hard to see this next part. So to find the slope, okay, so we're going to be looking for the slope. We could do it one of two ways. We could use the slope formula, okay, y2 minus y1 over x2 minus x1. And I'm going to zoom in a little bit more so you can see the graph a bit better. All right. This graph, this line right here, intersects the grid at some nice points. For instance, see these places where our lines intersect, these little points? Okay, I'm going to call that the grid. Somebody might call it something else, and I'm kind of just making up this name just so that you can understand what I'm referring to. I'm referring to these points right here, and I'm calling it the grid so you have some sort of name reference. This line right here, okay, intersects the grid at some nice points. Like if we look down here, it intersects right there, it intersects right here, it intersects right there, and all these points are very important. Because if I travel from one point where it intersects to another point where it intersects, we measure that distance as the change of y